one, Pythagorean theorem. We all know that the Pythagorean theorem is a squared plus b squared equals c squared, but what do those letters mean? Well, your a and your b's are your legs. So leg squared plus leg squared equals your hypotenuse squared. And the most important thing that you need to make sure you remember is, can you locate the hypotenuse correctly? Well, where does the hypotenuse lie on a right triangle? It's always opposite what? This is my right triangle. Hypotenuse is always opposite the right angle, right? And then your legs can be interchangeable. Doesn't matter which leg is A, which leg is B. Your legs are always the sides that create the right angle, right? Okay? Yeah, just I know. Okay, so using the Pythagorean theorem, we should be able to solve for any unknown side of a right triangle. So again, you need to make sure you always locate the hypotenuse correctly. Me personally, I always make a little arrow directly across from the right angle, and I put a little C there. And the reason why I care about that is because your C is always by itself. It's always alone in that equation of a squared plus b squared equals c squared. Then, doesn't matter which is A or B, I'm going to make 8 my A, 6 my B. So then we're going to do an a squared, which is 8 squared, plus 6 squared, and set that equal to x squared. Now it's some calculator work. If you're using the cheapo class calculators, you're going to have to do this by hand. 8 squared is 64, 6 squared is 36. Adding those together gets you 100, is equal to x squared. To undo a square, we take the square root of both sides. So we get 10 is equal to x. If you have a TI-30 where you can see like the whole entire string of numbers, which I have, my calculator on the board is going to be a TI-84, but you'll get the idea. If I wanted to do this all together in one shot, I could, on my calculator, if I can do the whole string, I can do the square root of 8 squared plus 6 squared, and then hit enter, and then it gets me the 10, right? Some calculators will let you do that. Like the TI-30s, you can put it all in one string like that, okay? If you don't have a fancy calculator like that, then you're just going to have to do each thing individually. Okay, let's go ahead and move on to the next one. We're solving for x, maybe. Solving for x. Did I change it yet? Nope. There it is. Okay, so where's your hypotenuse located? Is it the x, the 3, or the 5? The 5. Good. So my hypotenuse is down here. So there's my C. Doesn't matter which is my A, which is my B. So now I'm going to do an x squared plus 3 squared and set that equal to 5 squared. So now, if I didn't have a fancy calculator, then I would do x squared. 3 squared is 9. 5 squared is 25. Subtract 9 for both sides. So x squared is equal to, what is that, 15, 16? Well, that's nice. Square root of 16 is 4. So far, we've been pretty kind in our answers. If I was doing that on my calculator, so what I would see, I'm going to go up here to the top. So I have x squared plus 3 squared equals 5 squared. So what we could technically do is solve for x right away without doing any math. So subtract the 3 squared. X squared is equal to 5 squared minus 3 squared, and then square root it. So on my calculator, I could do the square root of 5 squared minus 3 squared all in one big line. It would get me that 4. Okay? All right, you got that, Logan? All right, let's go to this next one. Oops, do I not have the next one on there? Oh, there it is. Hypotenuse is, in this case, x. So there's your C. So we're going to do a 6 squared plus a 4 squared equals x squared. 36 plus 16 is going to get me what? 52. Oh boy, not as nice as 16 or 100, which means we have to simplify our radical. So what perfect square goes into 52? probably 4. So I'm going to try that first. So 52 divided by 4 on my calculator, I get 13. Will 13 be able to simplify any further? Nope. So that's going to be my two numbers. So 4 times 13. So I get 2 square roots of 13 is equal to x. Okay. So rule of thumb, if it's not a word problem, simplify your radicals. If it is a word problem, then you can just give me a decimal version of it. Because it wouldn't make sense if I said, go out and run 2 square roots 13 of a mile. You'd be like, what? What are you talking about? Or if I said, go out and run about 7.2 miles, then you would have a little bit better of an idea of what I'm talking about, right? Okay, so now let's throw in some word problems. It says a 16-foot ladder rests against the side of a house, and the base of the ladder is 4 feet away. Approximately how high above the ground is the top of the ladder? So here's our 16-foot ladder. The base is 4 feet away from the wall. We want to know how high up it is. So is x a hypotenuse or a leg? It's a leg. Good. So we're solving for a leg. So my hypotenuse is over here at 16. So I'm going to do an x squared plus a 4 squared and set it equal to 16 squared. So x squared is going to be equal to whatever 16 squared minus 4 squared is. So 16 squared minus 4 squared on my calculator gives me 240. Square root that answer. It's about 15, so I'm going to put approximately. Those are approximately signs. 15.5 feet would make a whole lot more sense than simplifying our radical. So word problems, and it says approximately, then approximate your decimal. Okay? All right, so let's see if you can set up the one without the diagram. It says the top of a ladder rests against a wall 23 feet above the ground. All right, so make your house. There's my house. Where's your house? Make your house on there. Draw your ladder resting against it. There's my ladder. Make your ladder. And then finish up that right triangle. Okay, so it says the top of the ladder rests against the wall 23 feet above ground. So now I do know that vertical distance is 23. The base is 6 feet away. How long of a ladder do we need? So my hypotenuse in this case is x. So 6 squared plus 23 squared is equal to x squared. And then I would just go on my calculator and do 6 squared plus 23 squared all together in one shot. And I get 565 is equal to x squared. Square rooting that answer tells us our ladder needs to be about 23.8 feet. Okay. So, question 4. Pythagorean theorem is only true for what type of triangle? It only will work on a right triangle. Good. Will not work on any other type of triangle. It has to be a right triangle. We do have other laws that we can use for not right triangles, but in this case, we can only solve it with right triangles. All right, flip on to the back. Questions so far with that? Now we're going to take it up a notch, and we're going to work inside of our triangles. So how can we find the area of an isosceles? What does isosceles mean again? 2 congruent sides. Good. So an isosceles triangle, so I'm just going to make a triangle here, with side lengths of 10, 13, and 13. So I'm going to make the left and the right be my 13s and my bottom being my 10. How do we find area of a triangle? 1/2 base times height. Good. So we need to do a 1/2 base times height for my area of a triangle. So area is equal to 1/2 base times height. Do we know the base of that triangle? Yes, it's 10. Do I know the height of that triangle? No. But I can solve for it. If I drop a perpendicular, remember our altitude is just the perpendicular line from the highest point down to the bottom, if this is isosceles, that point will hit at the midpoint of the base. So now, does everybody see how now I have, if I delete this left side, a right triangle where the height is my unknown x? What's the length of this base down here now? 5. So now let's set up our Pythagorean theorem. So x squared plus 5 squared is equal to 13 squared. So x squared is going to be equal to whatever 13 squared minus 5 squared is. So on my calculator, I'm going to do 13 squared minus 5 squared. 13 squared minus 5 squared. I get 144. What's the square root of 144? 12. So my height is 12. Now I can find my area. So I can either do half of 10, which is 5, times 12. Or I could take half of 12, which is 6, and multiply it by 10. Or I can multiply 10 times 120, or 12, which is 120, and take half of that. Either would get you to the correct answer of 60 meters squared. Okay, so try number 5 all on your own. See if you can get the area of that triangle. So your height for this one, what was your height when you solved it out? Did you get something like 9.94? 9.95. Oh yeah, 9.5. 9.95 for your height.
I got stuck once I got to 61.
So we cut this in half, so that'd be 15. So then we're doing 15 squared plus x squared equals 18 squared. Did you get that part?
No, I didn't. I did 15 plus 18.
Yeah, because 18 is your hypotenuse. So that needs to be all by itself, right? Because there's your right triangle. So when you solve that out, you should get your height to be about 9.95. So to find the area, it'd be 1/2 your base, which is 30, times the height, 9.95. When you multiply all of that, you should get something close to 149.25-ish feet squared. 0.5 times 30 times 9.95. Yeah, that's what I got. And then for the second one, I got a whole area of 240. If anybody took it all the way there, did you guys take it? So for number 6, you're doing 10 squared plus x squared equals 26 squared. So your height there should be 24. So 1/2 your base, which is 20, times your height, which is 24, gets you 10 times 24, so 240 meters squared. Okay. I just want to check to see if I need you to do Pythagorean triples. We might save that for next class. Yeah, I think we can save that for next class. All right, we'll save Pythagorean triples. Actually, let's just get in here. Let's do it. Let's finish it, then it'll be done. All right, Pythagorean triples. Have you heard of these before? So Pythagorean triples are any triangle of a right triangle whose side lengths are actual integers and positive. So a set of 3 positive integers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. So all side lengths have to be integers. They can't be decimals, so they can't be the radicals that are not perfect squares. So we have what's called the Pythagorean triple families, and then from those families, you can then create all different types of combos from them just by doing scalar multiplication of them. All right, so you do a scale factor of it. Okay, so I think in your notes I have the headers, the godfathers of each set, and then we can make all different combos from there. Probably the most easiest Pythagorean triple, if you remember nothing, you should remember the 3, 4, 5, because that's pretty easy. Okay, so we've got all our different sets of Pythagorean triples. 3, 4, 5, right? Because if I do 3 squared plus 4 squared, that would be 9 plus 16, which is 25. The square root of 25 is 5. So 3, 4, 5 would be 3 side lengths of a right triangle that are all integers. So if I double that, then I would have 6, 8, 10. That would be in that 3, 4, 5 family. Or if I tripled it, then I would have 9, 12, 15. Or if I multiplied by 4, then I would have 12, 16, 20, or so forth. Put dot, dot, dot going down. 5, 12, 13 is another Pythagorean triple. Or you could double that to 10, 24, 26. You could triple it, 15, 36. Well, it'd be 39, dot, 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 and just keep going down. 8, 15, 17, doubling it, 16, 30, 34, and then so forth. And then 7, 24, 25. You do not need to have these memorized. They are kind of nice to memorize them so you can come up with quick answers. But if you can memorize the basic ones, like these probably are the most basic, 3, 4, 5, 5, 12, 13, then you can get them by just doing your scalars. All right, so let's do this last example here. So find the length of the hypotenuse of the right triangle. Let's see if we can recognize what Pythagorean triple it would be. Since x is the hypotenuse, that means it has to be the largest leg or the largest side. If I reduce, what can I take out of both 10 and 24? We can take out
5 and 12.
Take out 2, right? So if I divide by 2 here and divide by 2 here, I get 5, 12. And then what should be the match to that? It should be 5, 12, 13, which means that x would have to be 26, because what do I have to take half of to get to the 13? 26. Could I have gotten there just by doing a Pythagorean theorem of a squared plus b squared equals? Yeah, I could. But sometimes it's nice to just recognize them, especially the 3, 4, 5s. I mean, that one's pretty easy. If you see a 3 and a 4, you know it has to be a 5, right? Okay, so that concludes